Hi, my name is Eric Schares, Collection Analysis Librarian at Iowa State University in the US. So first of all, thanks to the organizers of the workshop. I'm really honored to be part of the discussion today. Thanks for having me. And in my brief talk, I'm going to introduce some early results from a project I've been working on to look at reference data in OpenAlex. And so this project looks at what authors from a certain university are referencing when they write their own works. So what years are those references coming from, what journals are being used, and so on. And so I'm going to show a Jupyter notebook that really outlines my process. And this really has the first part is pulling the data. And in the interest of time, I won't be able to go through too many details on that. And the second part, once you've actually pulled the data, we're going to make some graphs with it. So the notebook is available here at this link on GitHub. And so again, the first part is actually pulling the data, and this can be a time-consuming process. But as we see, it can take kind of a long time to pull. So this is going to be 230 articles from January 1st from Iowa State University authors, and it takes about a half an hour to go into each one of those articles and look at the references at the end of each paper. So I'm going to skip all this and jump down to what happens after we pulled. So the first file that I make is called summary file, and so that's just a summary of the publication, the DOI, and the number of references at the end of that paper. And so right away we can see that there are some papers that are reporting 0 references. I can do some summary statistics. And so the median number of references is 24, and the mean is almost 33. And that's because there are some papers that have a great deal of references. So the max is 182 references in a single paper. How many papers are reporting 0 references? I've got 57 out of this set of 230. And even though some manual investigation shows that there are references there, that's about 25% of the data in this example data set. And so as folks in this group likely already know, that's a function of what's going on in Crossref. And so publishers deposit that reference information, and Crossref had in the past been able to publishers could opt in to keep that closed. Now that's no longer an option. So any reference data that's deposited will be automatically made open, and that's a welcome development. So now we've got all this data. We're looking at the number of references, and here's that big bar of 0 reported references coming out. So I can remove that with some pandas. Now here's the same bar with that removed. So this is down to 173 publications that have some number of references. And so you can see the scatter of the count. And way out here, we've got one paper with somewhere between 175 and 179. And this one, as we saw, was 182. We can also look at the cumulative distribution. So we've got the big spike here at 0. If we get rid of that, we can see, 20% have looks like 16 references or fewer, and on and on. So now that's just the number of references. We can look at the actual characteristics of each reference. So what year was each reference published? Some fun things to do. We can look at the oldest reference. So in 2021, this paper cited a work from 1889. So that's pretty cool. And we can also look at the histogram of those citations. And so again, you can see kind of a peak here at 2018. Again, all these are 2021 papers that are citing back to 2018. And then way down here at the bottom is that paper from 1889. So we had one paper that was by far and away the oldest in this set. We can also change the Y to the probability density. And so 2018 had about 7.5% of the references in this particular data set. We can also look at the cumulative distribution plot. We can also track one DOI of interest, so break it out. So we change one DOI to red. You can see, maybe if you squint, these the red blocks stacked up here, that's the references from each DOI, from that one DOI. And this graph is kind of cool. So the red is that one single DOI, and it's 42 or however many references, and the blue is the entire data set. And you can hover over and get the information on each one of those data points. You can also look at the cumulative distribution. So that red is that one paper. You can see it cites much older on average than the rest of the population. And we can also look at each individual paper. And so what's the year delta? So 2021 minus the year that was published. So this was 9 years old, this was 6 years old, and so on. We can see the average is about 8 years, the median, and then the average is about 11 years. And that's because we had one paper that was 132 years old when it got cited. So there's a lot of other, graphs and plots and things to kind of explore. Really the takeaway is that OpenAlex can only report what it knows about from Crossref. And I do have some comments already on the GitHub page of ways I could improve the performance of the API pulls and the OpenAlex API and make that a little faster. So think that's all for my time right now. Thanks very much, and I'm happy to answer any questions.